Alright, so we're going to talk about how to solve quadratics by factoring, and I'm looking specifically when the leading coefficient is 1, and by the leading coefficient I mean the number that goes in front of your x squared term. So if there is a 1 here, or if there's no number here, which if there's not a number it is 1, we're going to talk about those specific cases. Okay, so, and before we get into this, I want to talk about how to multiply what I'm going to call binomial expressions, okay? So bear with me here for this slight rabbit trail, but I think it's a really important rabbit trail. And what I want to talk about is when we have something like x plus 2 times x plus 3. When you multiply these, some people like to use the name FOIL. You know, you can call it whatever you want, but basically what you're doing is you're distributing. Okay, so you're doing x times x, then you're doing x times 3, then you're doing 2 times x, and then you're doing 2 times 3. When everything is said and done on this, the x's multiplied together are x squared. The x times the 3 is 3x. The 2 times the x is 2x. And the 2 times the 3 is 6. So altogether, when you're done with this, you should end up with x squared plus 5x, because 3x plus 2x is 5x, plus 6, okay? This right here, to go from this step down to this step, is called multiplication. So what you're doing is you're multiplying two binomial expressions. Binomial just means they have two parts to them. So bi means two and nomial means name. So they're literally two named things. So this one is x plus 2. The first thing is x. The second thing is 2. This one's x plus 3. So when you multiply these, this is the result. Okay? All factoring is going backwards. So this is called dividing, but you're never going to hear us say solve this quadratic by dividing. We're going to call it solving by factoring. Okay, that's all we're doing. So what I want you to do is I want you to imagine you have this polynomial right here, x squared plus 6x plus 8, and I'm just asking you to return it back to what it looked like before. Okay, so with that said, it's going to look something like this. I'm just going to leave the equals 0 there. Okay, and now let's think about this. Okay, let's think about the example we just did. So we had x plus 2 times x plus 3. When you multiplied this out, the first term was x squared. As a general rule, these work out nicely. The first, I can tell you right now, the first couple terms in here are going to be x and x because you're going to have to get x squared. I want you to think about the 2 and the 3 with me for a second. The 2 and the 3 got multiplied together to be 6. Which was that last number there. So our new 6 in this case is 8. Whatever two numbers we put in here, they're going to have to multiply to make 8. Okay? I'm going to say that they're going to have to actually add to make, in our case, 6. Because if you look at this example over here, we had x times 3, which was the 3x, and then we had 2 times x, which was the 2x, and together we had 3x and 2x. So we had this many x's and this many x's, and we added them together. So I'm going to say that whatever two numbers we pick here and here should add to make 6. So let's actually write that down. So we need two numbers that when multiplied are 8 and when added are 6. Is there supposed to be a comma there? I never know. I'm sorry to my middle school and high school English teachers. Okay, so we're looking for two numbers that when multiplied are 8 and when added are 6. So what I'll usually do is I'll just go through and make a list of all of the factors of 8. So the numbers that you could multiply to get 8, like all the whole numbers. Obviously there are a ton of decimals, but I don't really want to do that. So what I'll do is I'll say, okay, so the factors of 8 are like 1 and 8, obviously, 2 and 4. 3 doesn't go into 8. 4, we already kind of picked up 4 here. So 5, 6, 7, those don't go into 8. So our possible pairs of numbers are 1 and 8 and 2 and 4. And it's pretty easy to see here, right? We're looking for two numbers that when you add them are 6, right? So 2 and 4. So we'll put in a 2 and a 4 here, and we'll just put a plus sign in the middle here. Okay? So what we've got now is we've taken x squared plus 6x plus 8 and we've broken it down into x plus 2 times x plus 4. We have successfully divided this into its factors, hence the name factoring. Okay? So with that said now, this is going to get a little confusing because I'm going to have to draw some arrows. What we're going to do now is we're going to take this information and we're going to say, okay, so x plus 2 times x plus 4, when you multiply them, are equal to 0. We're not done yet, okay? So what we've done is we factored our expression, but it's still equal to 0. We still need to solve for x. Solving means that you're finding values for x that when you plug them into the original function, make it true. And the original equation, I should have said equation there, not function. The original equation was saying, hey, I'm looking for numbers that when I square them and I add 6 more of them and then I add 8, the result is 0. So in order for us to do that, we use what's called the zero-sum rule. Okay? And the way that this works is, I want you to think about this for a second. Okay? I want you to imagine that I have a couple numbers. Okay? And my numbers here, I'm going to be kind of goofy here. I'm going to call one of them green triangle. And I'm going to call the other one red square. I'm not going to tell you what the numbers are, but I'm going to say that when I multiply them, so they're in parentheses here, so they're multiplying, the result is 0. And so I want you to think about this for a second. If you multiply those two numbers, so green triangle and red square, whatever they stand for, you know, like 3 and 6 or something like that. Obviously, they're not 3 and 6 because that would be 18. But when you multiply them, you get 0. What does that tell you about those two numbers? I want you to think about it for a sec. If you're watching this video, use your brain for just a second here. I'm going to pause for a second here, and I want you to think about this. If you have two numbers that multiply and you get 0, what does that tell you about those two numbers? Okay. If you want to pause and think about it for a few more seconds so you can get it on your own and feel smart or something, whatever, go. I'm not saying you're dumb. I'm just saying. When I figure things out on my own, I get really excited. I'm like, oh, man, that's awesome. Okay, so if you want to pause it, go ahead and pause it now. Otherwise, I'm going to tell you something really important here. If you multiply two numbers and you get 0, I'm going to say that at least one of these two numbers is 0. I'm not sure which one is 0, but if you multiply two things and you get 0, like one of the numbers had to be 0. Think about it. If that wasn't the case, you would, let's say you multiply non-zero numbers like 2 and 3. You would always get some number. Even if you multiply a really small decimal like 0.00001 times 1, you'll still get something that's not 0. Okay? Now, it could be the case that both of them are 0, which, you know, cool. But in any case, the most important thing that you realize here is that if you multiply two things and they equal 0, that one of these things has to equal 0. So what I'm saying here is that one of these things, in other words, call this our green triangle and call this our red box, one of these things has to be 0. I'm not sure which one is 0, and this might sound weird to you, but what we're going to do is we're going to let them each take a turn being 0. So we don't know if x plus 2 is 0 or x plus 4 is 0. So we'll just say, all right, well, just like I do with my 4- and 5-year-old daughters, let's give each of you a turn being 0. So we're going to say, you know what, x plus 2, we'll let you be 0. And we'll solve for x, so that's easy. You just subtract 2 from both sides. So x equals 2 is one of the answers. And then we'll say, all right, x plus 4, we'll give you a chance being 0, because maybe you're 0. We don't know. So in this case, x would be -4, because you just subtract 4 on both sides, okay? So I'll write it in. Some of you are going to freak out. Like, how did you do that? So -4, -4. Okay. So when we do that, we get two solutions. We get apparently either x is equal to -2 or x is equal to -4. And I want you to think about this for a minute, because we're going to go back up now. And we're going to think about the original problem. The original problem was to solve this by factoring. Okay, so x squared plus 6x plus 8 is equal to 0. So what we're going to do then is we're going to check our answers, because supposedly what we've done is we found the only two numbers in the world that if you multiply them by themselves and you add 6 of them, 6 of itself, and then you add 8, you should get 0. So let's check and see if that actually happens. Okay, so I'm going to scroll down here, and we're going to rewrite the function, the original function, and check them. All right, so the original function was x squared plus 6x plus 8 supposedly is equal to 0. And we're going to check and see if x equals -2. If we plug in -2 for x, we're going to see if that actually works, if that makes that equation true. So let's go ahead and we're just going to come down here and try this equation with -2 in where the x is. So we're going to do -2 squared plus 6 times -2 plus 8. And supposedly that's equal to 0. I'm going to put a equal sign with a question mark there, because I'd like to see if it actually equals 0. For some of you this is a little confusing, but this is just kind of the way I like to do it. Some people just leave this off here. They don't put the equal 0, and then they just figure out what this expression equals. If it equals 0, cool. If it doesn't, not cool. All right, so -2 squared is going to be +4, plus 6 times -2 is -12, and then plus 8. And the question is, again, does this equal 0? So we've got 4 plus -12 plus 8. This is essentially 4 minus 12 plus 8. And if you do 4 minus 12, that would give you -8. And then if you add 8 to that, you get 0. So the question is, on the left side, we get 0. Does that equal 0 on the right side? It does. So this is really exciting. What we've done is we have managed to find a number that when you square it and add 6 of itself and then you add 8, you get 0. Now, it's kind of cool. I know a lot of you are like, I just want to be done with this class, and I want to be done with high school, and I get that. All right, let's try our other example, or solution. So our other solution was x is equal to -4. So let's try that. So we're going to do x squared, which is really -4 squared, plus 6 times x, and we're not going to put in x, we're going to put in -4. Wherever we see an x, we got to put in what we think the answer is, plus 8. And supposedly that's equal to 0. So -4 squared is 16. 6 times -4 is -24. And then plus 8. And the question is, does this actually equal 0? So 16 plus -24 plus 8. Well, look, so 16 plus -24, that's essentially 16 minus 24. So that's -8. And then, hey, look at that, plus 8. That would indeed give us 0. So does 0 actually equal 0? It does. So what we've done here is we have found two numbers that are solutions for this, okay? And those are the only two solutions in the whole world. So let's write our final answer here then. So I'm going to show you how to write this. So your final answer, whoa, hey now, I don't want a highlighter. Our final answer And the way that you write this is x is equal to, and then you list the lower numbers first, and then you're supposed to put these like little curly brackets around it. So that would be your final answer. And that is how you solve a quadratic by factoring. So the most important thing for you to do with these kinds of problems is to just practice them, okay? I promise you with practice you'll get better. I learned this the first time, and it just took me practicing a lot. Like, I didn't do very well on the first quiz or test that we had with factoring, but I just kept with it and I got better at it. So, all right, so we're going to solve this by factoring. And again, basically the idea here is that before this was like x, there was x here, there was an x here, and we multiplied this expression and ended up with x squared plus 7x plus 12 after we simplified everything. Okay, so the question is, what did we start with here to end up with x squared plus 7x plus 12? So we're going to look for two numbers. Hopefully you remember from last time, we need our two numbers here that we fill in. They are going to need to multiply to make 12 and add to make 7. So multiply to make 12, add to make 7. So what I'll usually do is I will write down the factors of 12. So I'm looking for numbers that when I multiply them give me 12. And I usually start out low and then go up. So like 1 and 12, and then I'll go to 2 and 6, 3 and 4, 5. 5's not a factor. That doesn't work. 6. I've already got 6. 7. 7's not a factor of 12. 8 doesn't go into 12. 9 doesn't go into 12. 10 doesn't go into 12. 11 doesn't go into 12. 12 we've already got right here. And then obviously anything more than 12 is not going to go into 12. So these are our factor pairs here. So we've got 1 and 12, 2 and 6, 3 and 4. We'll erase the 5 who tried to be a factor of 12 but unfortunately wasn't. And what we're looking for here is we're looking for a pair of factors that multiplies to 12. So we've got 1, 2, 3 here. These are our options. I'll number these. So here's our first option, second option, third option. Which one of these pairs, when you add the two numbers, adds to 7? This is really, honestly, if you know how to find pairs of factors that multiply to make a number, that add to make another number, you can factor. Okay? So anyway, if we look over here, we're looking for our pair to add to 7. So 1 and 12, if you add them, you get 13, so they're out. 2 and 6, when you add them, gets 8, which is very close, but that unfortunately is not 7. But check this out, 3 and 4. So let's try that. Let's try positive 3 and positive 4. All right, so, and if you're not sure if you did this correctly, just go back over here, take x plus 3 and x plus 4, and just multiply it out and see what you get. So I'm going to actually do that for this one. If you do x times x, that gives you x squared. Then you need to multiply x times 4. This is how you distribute. So you'll get plus x times 4. I'm going to write 4x. I always like to have the number in front of the x. The next thing you need to multiply is 3 times x. So when you do that, you get positive 3x. And the last thing you need to do is multiply 3 times 4. So that would be plus 12. And if you simplify this, you'll get x squared plus 7x, because 4x plus 3x is 7x, plus 12. And look at that. This right here is what we started with. So that means that when we factor this, or when we divided it into its two separate parts, we did it correctly. The reason we knew that is because we took what we thought the divided parts were, multiplied them together, and got x squared plus 7x plus 12. Okay? All right, so from here, what we're going to do is we're going to say, okay, we did this last time. If I have two things that are multiplying to equal 0, and in my last case, I did something goofy. I did like, all right, if I've got a green triangle and a red square, and they're multiplying to equal 0, then one of these two things has to be 0. So what we'll do is, I'm going to erase my lovely colorful shapes. And we're going to say, okay, well, either x plus 3 is equal to 0 or x plus 4 is equal to 0. I'm not sure which one is equal to 0. Maybe they're both 0. So what we'll do is we'll give each one a turn. So we'll say x plus 3, we'll let u equal 0. X plus 4, we will let u equal 0. And then if you solve here for each one, you'd subtract 3 on both sides here, and you would get x is equal to negative 3. That would be one of your solutions. And then over here, if you subtract 4 from both sides, you'll get x is equal to negative 4. That would be your other solution. What does it mean for something to be a solution? It means that when you take this number and you plug it back into the original equation up here, it should be true. This equation doesn't work for many numbers. If you tried 10, just think about it. Like try 10 here. 10 squared plus 7 times 10 plus 12. What does that actually equal? Sure as heck doesn't equal 0. 10 squared is 100 plus 70 plus 12. That's 182. When you plug in 10 into this equation for x, it does not equal 0. It equals 182. It's not even close. Okay? What we're saying here, by saying that x is negative 3 and negative 4, is we're saying that these numbers, if you plug them in where the x is, will equal 0. Let's just check those real quick. So our original equation was x, oh, don't want orange, x squared plus 7x plus 12 is equal to 0. Supposedly, when I try x equal to negative 3, this should work. So let's try it. So we'll do x squared, which is negative 3 squared, plus, please, by the way, when you check these, use parentheses, especially if you're somebody who's lazy or doesn't remember how to multiply things and you use your calculator frequently. We know you're out there. Make sure you put those in parentheses. So plus 7 times x, where x is negative 3, plus 12. The question is, does this actually equal 0? So negative 3 squared is 9. By the way, the reason that that's 9 is because you're doing negative 3 times negative 3. You're not doing negative 3 squared. You're doing negative 3 squared. All right. 7 times negative 3 is going to be minus 21. And then plus 12. Does that actually equal 0? So if you do 9 minus 21, that would give you negative 12. And if you add 12 to it, you get 0. So does 0 equal 0? It sure does. By the way, if you try to plug in your number and it doesn't work here and it doesn't equal 0, then your number is wrong. That means you messed up somewhere. I don't know where you messed up along the way, but you messed up somewhere. All right. So our other solution, theoretically, was x is equal to negative 4. So if x is equal to negative 4, then we'll do x squared, which is negative 4, squared, plus 7x, where x is negative 4, plus 12. And the question is, does this actually equal 0? So negative 4 squared is 16. This is going to be minus 28 plus 12. Does this actually equal 0? 16 minus 28 is negative 12. And then when you add 12, look at that, you get 0. So does 0 equal 0? It sure does, last time I checked. All right, so what's our answer here then? Our answer, now that we've checked both solutions to make sure they work, is that x is equal to negative 4 and negative 3. We'll use our little curly brackets here. That's our answer. Let's do another one. All right. This one is x squared plus x minus 12 is equal to 0. And now it's starting to get a little trickier. The first couple weren't too terribly difficult, but hopefully you're starting to get the hang of this, that we're going to write a couple pairs of parentheses. We're going to say it's equal to 0. Obviously, if we start with x squared, that means that the first two things multiplied together need to result in x squared. So x times x makes sense. Now we're looking for two numbers that multiply to make negative 12 that add to make, there's not a number here, but you can essentially think of it as a 1 there, okay? So essentially 1. So we're looking for a couple numbers that multiply to make negative 12 that add to make 1. Okay, so what I like to do on these, and what helps me think about these, is I'm looking for two numbers. So don't worry about the negative for a second. I'm looking for two numbers that multiply to make 12 that are essentially 1 apart from each other, because one of them will be positive and one of them will be negative. The only way to get a negative number when you multiply two numbers is if one of the numbers is positive, one of the numbers is negative. So if you think about it, you're going to be subtracting something and adding something, and the result will be 1, which means that the numbers will be 1 apart from each other. And so let's write down the factors of 12. 12 is not a large number, so we can write down the factors of 12 pretty easily. So that's 1 and 12, 2 and 6, 3 and 4. And what you'll notice here is 3 and 4 are 1 apart from each other. And so what we'll do is we'll do a 3 and a 4, and we just need to pick which one of them is negative and which one of them is positive. And the answer to which one should be positive, which one should be negative, is right here with this plus sign. If we do negative 3 and positive 4, that would give us positive 1. So if you do negative 3 plus 4, that would give you the plus 1 there that you need. If you're not sure that this works, come over and do x minus 3 times x plus 4, but I promise you it works. And so now what we'll do is we'll take each factor here. So this right here, x minus 3 is a factor, x plus 4 is a factor. When those factors are multiplied together, they give you x squared plus x minus 12. So all we're going to do now is set each one equal to 0, give each one a term being 0, and then we'll get our solution. Okay, so we'll add 3 here to both sides. So we get x is equal to 3. On this one, we'll subtract 4 from both sides. And we'll get x must be equal to negative 4. So those are our two solutions. If you check them, they work. Always recommend checking them. So our final answer is going to be x is equal to negative 4, comma 3 with the little curly brackets. Let's look at another example here. So this should be x squared minus 2x minus 15 is equal to 0. I forgot to put the equal 0 there. It's kind of hard to solve if you don't have an equation. Otherwise, you just have an expression, and you can't really solve an expression. It'd be like if somebody said, solve 4x. And you'd be like, what? All right, anyway, it's late, and I'm going off on random tangents. So this is going to break down. When we divide this, it's going to be x and x. Looking for two numbers that multiply to make negative 15 that add to make negative 2. So that tells me that I'm looking for two numbers that multiply to make 15 that are 2 apart from each other. So 15, I'm just going to write down the factors of 15. 1 and 15, oh, not 1 and 5, 1 and 15. 2 doesn't go into 15. 3 goes into 15. 3 times 5. 4 doesn't go into 15. 5, I'm literally just going up the list of numbers that could possibly be factors of 15. So 1, 2, 3, 4. 4 doesn't go into 15. 5, I've already got 5 here. 5 times 3. I don't really need to rewrite it. 6 does not go into 15. 7 doesn't go into 15. 8 doesn't go into 15. Really, if you think about it, any number more than half of 15, there's no way it could possibly go into 15, right? Like 10, if you count off the multiples of 10 are like 10, 20, 30, you know. So once I get to like 7 or 8, I think there's nothing else that could possibly go into 15. So we're looking for a couple numbers that are one of them will be negative, and when we add them, we'll get -2, which really means that those numbers need to be 2 apart from each other. So these are 14 apart from each other. These are 2 apart from each other. So we're going to want 3 and 5. The question is, which one is positive, which one is negative? We need it so that when we add the 2 numbers, one of them will be negative, one of them will be positive. When we add them, we need to get -2. I'm going to say that means that the 5 needs to be negative and the 3 needs to be positive. If you make it the other way, you'll get +2. Okay, so... all right, from here, we've got a couple things multiplying to equal 0. So one of those things needs to be 0. We're not really sure which one, so we'll let both have a term being 0. So x plus 3 is 0, x minus 5 is 0. If you solve for x here, you'll subtract 3 on both sides. You'll get x is equal to -3. And on this one, you'll add 5 to both sides, and you'll get x is equal to 5. So your solution here would be x is equal to -3, 5. You should check your answer. But those are the answers. All right, let's try some even trickier ones. Okay, so we got different combos here. Another combo I want to try is where, so we're going to break this down. We know it's going to break down like the other ones. It's going to be x here and x here, but this one's a little different because what we've got now is we're looking for 2 numbers that multiply to make +12 that add to make -8. And so if you got 2 numbers that multiply to make +12, they're either both going to be positive, so you're going to have a positive times a positive, or you'll have a negative times a negative. Those are the only possible ways that you could end up with a +12. But with that in mind, I want you to think about this. We need our 2 numbers to add to make -8. So if you take 2 positive numbers and add them, think about this. If you take a positive number and you add it to a positive number, the result will be a positive number. If you take a negative number and you add it with a negative number, your result will be even more negative. So what I'm trying to say here is that this is the case that we want to consider. This right here, not going to work. Okay, so we're going to be working with 2 negative numbers is what I'm trying to say. So I need a couple negative numbers that when I multiply them, they give me 12, and when I add them, they give me -8. So let's write down the factors of 12. 12, that's 1 and 12, 2 and 6, 3 and 4. Obviously, they're all going to be negative, so I mean, I could throw in negatives here, but I kind of already wrote them out, so let's maybe not do that. They're all going to be negative, okay? So we're looking for a couple things that when we add them together, we get -8 there. So I'm going to say the 2 and the 6 are what we want. So the 2 and the 6, and they're both going to be negative. And then from here, it's the same process. So if you've got something times something, and it's equal to 0, what does that mean? It means either x minus 2 is equal to 0, or x minus 6 is equal to 0. We're not sure which one. We'll give them each a chance. Solve for x here, so add 2 to both sides. Then x would equal 2 here. And if you come over here and add 6 to both sides, you would get x is equal to 6. So that's your solution there. So your final answer here would be x is equal to 2, 6. And you should obviously go back and check those. Make sure that when you do 2 squared minus 8 times 2 plus 12 gives you 0, which it does. And when you do 6 squared minus 8 times 6 plus 12 gives you 0. They do. I checked them. I promise they work. All right, last one here I want to try. And that is x squared minus 10x plus 16 is equal to 0. I keep forgetting to put the equals 0. All right, so we're going to look for 2 numbers that multiply to make 16, that add to make -10. So multiply to make 16, add to make negative 10. That means they're both going to have to be negative again. And the reason I know that is because we're going to have to multiply to make a positive number, but we're adding to make a negative number. So, all right, 1 and 16, 2 and 8, 3 doesn't go into 16, 4 and 4, 5 doesn't go into 16, 6 does not go into 16, 7 doesn't go into 16, 8, I've already got 8, and I'm already halfway there, so I don't need to bother checking anything else. I'm looking for a couple numbers that when I put them together will give me 10 here, specifically negative 10. I should have written negatives for these, but sometimes I get a little lazy. I'm going to say the 2 and the 8 should work. 1 and 16 would give us 17, 4 and 4 gives us 8. So we're going to do 2 and 8, and they both need to be negative, so x minus 2 and x minus 8. So we'll let each one be equal to 0. So from here, add 2 to both sides. You'll get x is equal to 2. And on this one, if we add 8 to both sides, we'll get x is equal to 8. That's our other solution. So our final answer will be x is equal to 2, 8.